So the last thing we're going to go over in probability is how to use a sample space diagram to find probabilities. So we're going to look at a couple different ones. So in the video, we're going to talk about a grid or a table. And then in class, we will talk about the tree diagram. So first, what is a sample space diagram? It's just basically a graphical way of showing the possible equally likely outcomes of an experiment rather than just listing them. So it's just an alternative way to just show your possible outcomes. If you want to keep listing or do whatever you'd like, you definitely can do that. I just wanted to show you some alternatives. So we're going to use a grid or a table with the first example. So if two fair dice are rolled together, we want to calculate some probabilities. So the first thing we want to know is, well, what are the outcomes of your two dice? And we're going to assume these are typical dice that are six-sided. So the grid is something like this. You basically create a plot of the possible outcomes. So for example, if we call this vertical axis dice 1 and this horizontal axis dice 2, what you want to do is show the possible outcomes for each dice, kind of like the way you would graph. So 1, 2, 3, 4, 5, 6, right? And 1, 2, 3, 4, 5, 6. So what you're creating is you're basically creating this little scatter plot of the possible situations. So you can have 1 and 1 show up, 1 and 2, 1 and 3, etc. Okay, so each of those light blue dots represents a possible outcome. So you can roll a 2 and a 1, a 3 and a 5, etc. So it's just a different way of listing it. You can also just make a table showing the same information. So for example, again, we can have dice 1, right, with 1 through 6. So here's dice 1. And again, dice 2 with 1 through 6. And with the table, it's just a table of outcomes. So what I do is just list it. So you're going to have basically a space representing each possible outcome. So, for example, you can roll dice 1, get 1, and roll dice 2 and also get 1, right? You can roll dice 1 and get 2, and roll dice 2 and get 1. So, and if it helps, you can put a comma between them so you see it's not 11 and 21. But you're just listing the possible outcomes, right? Roll a 3 for dice 1, and get 1 for dice 2, etc. So it's, again, basically the same information, just written out as a table. Okay, so these are just two diagrams, basically show the same thing. Some people might like the dots, so it's a little cleaner. Some people might like the numbers. Like me, personally, like seeing the numbers, so then I can think about what I'm given. So let's go ahead and look at some probabilities. So part A, what's the probability the total score is 5? So you want to basically add the two numbers and get 5. So the nice thing about the dots is, you know, for example, 1 plus 4 is 5, 2 plus 3 is 5. So you'll notice that we're basically looking at this diagonal, right? Because 3 plus 2 is 5, but 3 plus 1 is 4, for example. And then you can clearly see there's 4 possibilities. But you can do the same thing here in the table, right? You might recognize 4 and 1, 3 and 2, 2 and 3, 1 and 4. But regardless, we want to figure out that probability. I'm going to say the probability that the sum is 5, so that's going to be 4 out of, and the great thing about the sample space, it's actually a lot easier to find the total values, the total outcome. So 6 times 6 is 36, so 4 out of 36, or 1/9. Okay, part B, let me erase my highlight. Okay, so what's the probability that we get the same number? So same number, again, you can look right across on the table. It's 1, 1, 2, 2, 3, 3, 4, 4, so right along the diagonal. Similarly, on the dots, right along that diagonal, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And we get 1, 2, 3, 4, 5, 6 possibilities out of 36. So again, just hopefully a visual way of seeing your possible outcomes. Okay? Go ahead and try C and D, and let's come back and check your answers. So the difference between the score is 1 and the score on dice 1 is less than the score on dice 2.
So hopefully for the probability of the difference equaling 1, you got 10 out of 36, which reduces to 5 out of 18. If you're not sure where those 10 came from, let's check your table or check your grid. So the difference is 1, we want to think about like 2 minus 1, right? 3 minus 2, 4 minus 3, 5 minus 4, 6 minus 5. And conversely, right, here's a 6 minus 5, 5 minus 4, 4 minus 3, 3 minus 2, 2 minus 1. So those are my 10 options there. All right. Let me go ahead and erase that, and let's look at D. Okay, and part D, what's the probability of the score on dice 1 is less than dice 2? Well, if you think about it, we want the red number in this table to be less than the blue number. So here I can already see 2 is greater than 1, right? 3 is greater than 2. So this diagonal kind of is the boundary for this entire region. So these are all the numbers that have the blue being greater than the red. So hopefully you guys all found that to be 15 out of the total 36, which can reduce down to 5 over 12. Okay, so that is using the grid in the table.
If we look at example 2, we can look at an example where we have no replacement, which means the second probability is kind of affected by what happens first. So if you look at example 2, 4 identical cards are numbered 1, 2, 3, 4, placed in a bag. One card is drawn and not replaced. So that means the total is changing every time we draw a card. The second card is then chosen. We want to find these probabilities. So if you wanted to draw this, for example, as a grid, I might do, one being card 1 and the second being card 2. And there's 1, 2, 3, 4 possibilities for each card. Oops. 1, 2, 3, 4. Right? 1, 2, 3, 4. But when you want to come up with the possible outcomes, this time it's a little different. Because if I draw 1 first, can I draw 1 second? No, it's already gone. So if I draw 1 for card 1, I can only draw 2, 3, or 4 for card 2. Right? If I draw 2 for card 1, then I can only draw 1, 3, and 4 because card 2 was taken out. So hopefully you're seeing this pattern, right? We just can't draw itself, so we're going to have this blank diagonal all the way up in this sample space. Okay? Similarly, you can do the same thing in your table, right? So if I have my table with card 1, with possibilities 1, 2, 3, and 4, and card 2, with possibilities 1, 2, 3, and 4, you should once again see we would have a blank diagonal as we go up. Because using a little logic, if I don't replace the card is completely gone from the problem. So if I pick 1 as my first card, I can only pick 2, 3, or 4, because 1 was taken out of the picture. So if it helps, you can just immediately cross off any of those, repeated numbers, because we can't pick itself if it's not in the back. Okay, so those are my possible sample spaces. So now let's calculate these probabilities. So A, what's the probability that the larger number is not prime? So once again, if you look, what are the possibilities? So if I want to look at the larger number, for example, 2 is bigger than 1, but it's prime, right? So I don't want that. 3 is also prime, so I don't want that either. 4 is not prime, and 4 is larger than 1, 2, and 3. So I have a possibility of 3 out of a total 6 and 6, right? 12 outcomes. So that reduces to 1/4. Okay? B, the sum of the cards is less than 6, and C, an odd number is chosen. Go ahead and try those with these two new sample spaces, and let's check your work. All right, so if we want to look for sums less than 6, for me personally, I just like looking at the table because then I can just see what the possibilities are. So, right, 4 and 1, 3 and 1, 2 and 1, 3 and 2, 1 and 2, 1 and 3, 2 and 3, and 1 and 4. So I've highlighted 1, 2, 3, 4, 5, 6, 7, 8 out of, again, the total 12. So hopefully you guys all got 2 out of 3. Okay, and finally, at least one odd number, so it doesn't matter where. So again, you can highlight or circle or whatever you want, either on your sample spaces. So I know at least one odd means we need, you know, a 3, anything with the 3, anything with the 1s, going both directions, right? So I can have a 1 for card 1 or a 1 in card 2, right? 3 in card 1 or 3 in card 2. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the total 12. So that's going to give me 3/4 as my probability. So that once again is just using a sample space, showing it as a table or a grid. Up to you if you'd like to use it, but it's important to think about possibilities with replacement and without replacement. Okay? Thanks for listening. We'll talk about tree diagrams in class.